Hello, students. I have a beautiful question for you guys. Solve using matrix method the simultaneous equation. We have it this way. Okay, this is one of the things applications, of course, of matrix. So let's work it out. Solution now. Now we are to solve this simultaneously. The first thing you need to do is make matrix of it. Remember, matrix is the rectangular array of numbers. So we are going to make matrix of this by picking the coefficients. So we pick this, okay, you see you have 5, then we pick 2, and we have 7, and we have 4. Okay, we've picked the matrix. Remember the unknown, x and y, so we have our x, y. And of course, it's equals to these two. We are going to have 4, 8. That's the very first step, which is very important. Now, the next step is this. I'm going to give you some very good explanation now. If this matrix is A, and let's say this matrix is X, and let's say this matrix is B. Do you know what it means? It means A times X is equals to B. That is AX is equals to B. Now, the knowledge here is once a matrix is being multiplied, is being pre-multiplied by its inverse, it gives an identity matrix. So it means if I've had the inverse of A multiplying this, then of course you do for both sides. This particular multiplication will give you an identity matrix. And any matrix you multiply by its identity matrix, it remains the same. So that is the knowledge we are going to use. All right. So follow me now and check out what I'm going to be doing. Now, let me get A. We say A. Let's say A is equals to 5. Let me not rush it. So A is equals to, we have 5, 2, 7, 4. Now I need to get the inverse of A. Now, how do I get inverse of A? Inverse of A is going to be 1 all over determinant of A. Then into, now, this is what is going to happen. I'm going to change the right diagonal. I'm changing it, so there's going to be 4, then 5. That is the method of doing it. Then this left diagonal, I'm going to multiply by negative. So it's going to be -7. Then I have -2. Okay. Now, what I need to find is the determinant of A. Determinant of A now will be the right diagonal, which is 5 times 4, minus the left diagonal, which is 7 times 2. Now, this is 20 minus 14, and the answer is 6. So, my inverse will be 1 all over 6. Then, of course, we have 4 minus 2, then -7 and 5. This is the inverse. So remember, we are pre-multiplying. So putting it together, I'm going to have 1 over 6. Then we have 4 minus 2, then -7 and 5. Then, of course, what is my A? My A is 5274. 5274. Good. Then, of course, I have my x, y. Then is equals to, remember, we are pre-multiplying both sides. So we have 4 minus 2, then -7 and 5. Then we are going to have 4 and 8. So 4 and 8. Okay, beautiful. So now in multiplying this, I'm going to have 1 over 6. Okay. Now, this is the multiplication. 4 times 5, 20, minus 2 times 7, minus 14. Then 4 times 2, we have 8. Minus 2 times 4, we have -8. Then 4, we move to the next. -7 times 5, we have -35. then 5 times this, we are going to have plus 35, all right? Then minus 7 times this is minus 14. Then 5 times this, we have plus 20. This is what we are going to have. Of course, we have our x, y, then is equals to, we have 1 over 6, okay? Then here we have, of course, 4 times 4, we have 16. Then this is minus 16. Very good. Then we have minus 7 times this, we have minus 28. Then this, we have plus 40. This is what we have. Now, of course, we know that this will go with this, all right? Or if you don't want to do it this way, then this is what you are going to do. So let me not go too fast for you. So let me take this off. Let me take this off and I follow it gradually. So you have your 1 over 6 and you have your 1 over 6 here. So now this is going to be 1 over 6 into, of course, you are going to have 6, 0, then 0, 6, then x, y is equals to 1 over 6. We have 0, then we have 12, right? Good. We have 12. Good. Now, check it out. This, when we multiply, we are going to have 1, 0, 0, 1. Of course, that is the identity matrix I told you about. This x, y, then is equals to 1 over 6. Then we have 0, we have 2. Now, listen. The rule is that whatever multiplies an identity matrix remains the same. Okay, so when you multiply this, you are still going to have your x, y. Now, is equals to, now you can see this is 0 and 2. All right, so we can compare the position of the terms so that x is equals to 0 and y is equals to 2. So, ladies and gentlemen, we solved this question where x is 0, y is equals to 2. You cannot come back if you wish to put in your values here, and you will find out that you will get your answer exactly. All right. So thank you for watching, and don't forget to subscribe.